Hello. Okay. Hi, and in this video, we'll be learning about doubly linked list. So, what is doubly linked list? It's similar as a singly linked list, but in the last video, we have covered the singly linked list, and it's generally termed as linked list. Okay, so if somebody is calling linked list, they are generally pointing towards the singly linked list. Okay, but linked list are of different types. So, one type is singly linked list, other type is doubly linked list, and then also there are further more types, circular linked list, and so on. But yeah, let's talk about doubly linked list. So this is a very popular type of linked list, and it's considered to be much better than singly linked list in terms of accessibility. Like if you want to go, if I just talk about singly linked list, if you are at a node, you can't go at the previous node, but you can go at the next node. Okay, so this is the benefit of singly linked list. Okay, this is the benefit of singly linked list. You can go at the next node, but this is the fault of singly linked list that you can't go at the previous node. Okay, so this can be actually solved by doubly linked list. Doubly linked list simply means that you have your node stores three values: previous pointers value, okay, previous nodes value, current nodes value, next nodes value. Okay, previous simply means that whatever is the address of previous node will be stored. Next is simply storing the value of next node, okay, the address of next node. And then we have the third thing, which is the data. So we basically have three things in doubly linked list: previous, data, next. In singly linked list, we had two things: data, next. Okay, so I hope you understood the difference. So let me just show you with a proper diagram so that you get a better idea how doubly linked list looks like. Okay, so if you haven't watched my previous videos on this data structures using JavaScript playlist, please watch that so that you get a better idea of how I have taught linked list and how we perform some operation on singly linked list. Then you can better understand this video because this is properly linked to the last video of linked list. Okay, so one more thing, in the live chat you'll find a link of a course provided by Geeks4Geeks. So once you visit that link, it will take you to a specific page provided by Geeks4Geeks, and it's actually a course. Okay, so you can just visit there, and here you will find the description, and you can also check the content of this course. It's actually for learning data structures using JavaScript. So if you want to learn DSA in JavaScript, you can check out this course. This is a very great course. Okay, and like suppose some people have doubts, why is this useful? Why should I learn it in JavaScript? Why not in any other language? You can definitely learn DSA in any other language, but specifically if I talk about JavaScript, JavaScript is used widely in web development and app development. So if you learn DSA in JavaScript, it will be really helpful to build optimized websites and applications. That's why it's important to learn in JavaScript also. Although if you have learned DSA in some other language, you would find very easy. DSA concepts are same in any other language if we compare to JavaScript. Okay, so you can, if you learned DSA in JavaScript, you can learn it in any other language later on. Okay, so vice versa. Alright, so you can see everything is covered from basics to advanced. So do check out this one. This is a paid course. Alright, so now let's continue, and I'll be opening whiteboard first so that we can draw some figures. Alright, okay, I think we have some people on the live chat. Sir Python, Artificial Intelligence course, PI Live. Uh, definitely, somebody might bring that specific course on this channel. I'm not sure who will be the in charge of that, but definitely I don't know much about AI right now. But definitely, if I someday will be bringing the course. Okay, so now let's continue. And what I'll be doing is, I think I have drawn singly linked list things here. Okay, I'm actually referring to the last video's whiteboard so that you get a better idea, yeah, how singly linked list work, so that we get a better understanding of how doubly linked list work. Okay, so I'll just zoom it a bit, and you can actually see we have different kind of operations on any linked list. If I talk about linked list, generally it's singly linked list. So you can see we have performed append operation, print operation, prepend operation, insert in between operation, delete operation in a singly linked list. But today what we'll be doing is we'll be performing those operations in a doubly linked list. Okay, so let's do that. And I think I have drawn append operations here also. So let's check first. Yeah. Okay, guys, I think we don't have the specific sheet for that. Let it be. We might have missed it out. Let it be. So what I'll do is I'll just show you the difference by drawing both of them. Okay, by drawing both of them. So yeah, this was the sheet for doubly linked list. Let's start. Just a minute. All right, we are fine. And what I'll do is I'll just zoom it a bit. Okay, yes. So let's draw both of them. So if I talk about singly linked list, okay, singly linked list, okay, and then we have some other type named as a doubly, which we are learning today, okay, doubly linked list. So let's try to understand the differences. So singly linked list, it's simple. If I just draw a diagram of it, a simple node, okay, I'll be drawing a node for it. So you can say that suppose this is my first node, and I don't know why it's okay. Just a minute. Yeah, now it's fine. Yes. So now you can see that this is a very basic node. This node actually contains first value is what? Data, whatever is the data inside this node. But the second value is what? The address of next node. Okay, this is what? A singly linked list. So it will be pointing to some other node. Okay, but some other node can't point to the previous node. What I mean is it has another value of, okay, so it has another value of again the data and then the value of next address. So next, okay, fine. So you can see we can go from one place. Suppose it has value of 5, data is 5, is its data is 6. The address of next node, this node is actually x1, and the address of next node, that is this new node, is suppose suppose x2. So you can see that it contains two values. This specific node contains two values, 6 and x2. That is 6 is data and next address is x2. That means if I want to go to the next node, I'll check for the address x2. Yes, I'll go to that node which has address x2, right? So this specific node has address x2, its address is x2. It will again contain some value, suppose 7, and it has some address x3. That means next address is x3. Next node's address is x3. So you can see I can go to the next node by simply referring to this address, okay, the next address. But I can't if I am here. Suppose we are at here, okay, we are actually at here currently. So there is no way I can actually go to the previous node. Okay, I can't actually go to the previous node, but I can actually go to the next node. Okay, so this is the benefit of synced list, that you can go to the next node, but this is the fault of single linked list, that you cannot go to the previous node. Okay, so how to overcome that? Overcome that? So for that, we actually use doubly linked list. So doubly linked list is very easy. What you need to do is, suppose you have the same scenario, but this time again you have the same node. Okay, same node 5, but this time it has, first of all, its data is 5. Okay, and then it has some previous address. Okay, previous node's address, which will be null in this case. First node will be always be having previous as null. Then it has some data, that is 5, and it has some value for the next address. Okay, so it actually points to some next node also, and it points to some previous node also. Okay, so suppose I have some next node. Okay, some next node is suppose 6. It will again have some previous value, some data, and again some next value. Okay, so previous, data, next, and obviously it will be pointing to previous node by simply some previous address. Okay, so suppose the address of this node is x1. Suppose the address of this node is x1, or for better I would write it as x0, and it has some address x1. That means the next of this is actually equal to x1. That means this 5 is pointing to some next address x1. Okay, and similarly previous is equal to null, because since it is the first node, 5 is the first node, it will be having previous as null. Similarly, if I talk about 6, we are considering that we only have two nodes, so its next is equal to null, because we don't have any other node after this. If we had, then it will be pointing to that new address. Previous of this is actually equal to x0. Okay, x0, previous of this node is actually equal to x0. That means if I want to go the previous node, 6 6 is previous node. Okay, that means previous is having value x0. That means I want to go to that node whose address is x0. That means I can simply go to the previous node. Okay, it's like that. So this is actually example of doubly linked list. Rest everything is same. If I compare to singly linked list and doubly linked list, rest everything is same. Okay, it just makes things easier. But the problem with doubly linked list is you can see that a single node is actually storing three values: previous, data, next. But in singly linked list, it stores only two values: data and next. So obviously this will be consuming less memory as I compare to doubly linked list. Okay, so that's the benefit of singly linked list, that it stores only two values, and doubly linked list, it stores only three values. That means it stores more values than the singly linked list, so obviously it will be taking more memory. Okay, it will be taking more memory, but it's more efficient, it's taking less memory. It's like that. Okay, so now we'll be continuing with the coding part. So let's draw some functions which we'll be using. Okay, so first of all, any node will be having three things. That is, first of all, you'll be having data, then the previous, and the next. Okay, initially all these three will be null. Okay, so let's try to write the code for that. So first of all, in the last video we did the same. Okay, so I'll just copy this and I'll just paste it here. Okay, so I've just opened a VS Code terminal here, and you can see that it's a window, and you can see I've created a file script 2. In the last video we created script1.js, so please watch that, operations on linked list part 1. And for that you can just visit Geeks4Geeks practice channel. Here you'll find a playlist of data structures using JavaScript, so you can visit that playlist and you can watch all the videos. So in script2.js, here you'll find that we have created next as null, but we need one more parameter, that is this dot previous. Okay, I think the spelling is correct. Fine. Yes, fine. So here you can see that, yeah, we have these two things. Okay, that is next and previous, and then we'll be having a data. Okay, so that's how you'll be always creating a node. Okay, this is how you create a node. Initially you don't know whether it's pointing to backward or forward, where it's pointing to. You don't know anything. You just make next and previous as null. Okay, initially we just do this, and later on we assign the values when we perform operations. Okay, so first of all, you create a node every time. Okay, whenever you are performing some addition operation. Okay, so now I'll just say that let's have a class, and let's name it as class doubly linked list. Fine. So this is a class doubly linked list. Inside this, you will be having a constructor first of all. So let's go there, and you can see that in here we had a constructor. So I'll just copy this and I will paste it here. Just a minute. Yes, so here you can see that what we did was we made a head pointer as null. Similarly, we'll be creating a tail pointer. So tail will always be pointing to the last node and head will always be pointing to the first node. Okay, so we'll see the use of tail, but yeah, just declare the constructor like this, and then we'll just say that you can also, if you want to know the length, you can just say this dot initial length is 0 whenever you declare a linked list, doubly linked list. Obviously the length will be 0, then you create first node, the length will become plus plus, that is 1. Again second node length will become 2. It's like that. Okay, so let's create the first operation. We can say that if we need to check that if suppose it's empty, so I'll just say that if it's empty, you can actually check by simply returning the length. If the length is equal to 0, it will be true, else it will be false. So this is very easy. There is a function to check where the list is empty or not. Okay, so that's why we have written it like this. Okay, so this is a very basic function. Then we can also, suppose we want to get the length, so we'll be simply returning the length. Okay, the length. So these are some basic functions. Then we'll be performing the append operation. So append operation requires data. Okay, whatever is the data. Append simply means that you will be adding new value at the last. Okay, so if I give you an example of append, let's draw it here. So you can see that this was a doubly linked list. Okay, suppose I'll just draw it again here. Okay, and for better understanding, what I'll do is I'll just draw a format of node format is of what? I'll be drawing nodes in this format. So suppose this is a node, it has three values. Okay, three values. One is the previous pointer, next is the data of that node, and then the next pointer. Okay, next address. So I'll be drawing it this way so that it becomes easier. So suppose you have a linked list, and suppose this is the first block, and it has suppose some value, like it has value 5, and it's previously pointing to null. So what I'll do is I'll just leave it as empty, so that, or I'll just write null. Okay, null, and it's pointing to some address x2 or x1, suppose x1. Okay, x1, and the address of this specific node is x0. Okay, for your better understanding, I'll just say that address of this node is x0. So I'll just write x0 with some different. Okay, so I'll just write address here x0 so that you get a better understanding. So the address of this whole node is x0, but it's pointing to x1, that is next one, and previous is null. We don't have any node before because this is the first node. Okay, suppose we have some other node. Okay, so this is some other node, and again it's pointing to address x0. That means it's pointing to this previous node. Okay, this previous node. So I'll just draw it better. Fine. This is the previous node, it's pointing it here, and the previous node is also pointing here, right? Previous node is also pointing here. That means this x1 actually is this node. Okay, so I'll just write the address of this node, that is x1. Fine, I hope you are getting this. So again I'll just say that suppose it's having value 6, and then it's pointing to next address, that is x2. But you know that we don't have any address after this. That means we only have suppose two nodes, we don't have a third node. We want to append a new node. Append simply means adding a new node here after this. Okay, that means after this. So how we can actually do that? First of all, you'll be creating a node. I have created a new node. Okay, first of all, you will be creating a node. Initially it will be having previous as null, and suppose the value is 7, and the next is null. Fine, and suppose the address of this node is x2. Fine. So now what you'll do is you'll just say the append operation simply works like you'll simply say that the new nodes previous. Okay, one more thing. Always you need to check that I'll just give you an example of an empty node, okay, so that you get a better example. Suppose the linked list is empty. We'll come to that back, okay, just wait. But suppose the linked list is empty. Suppose the linked list is empty. So what would actually happen is you called an append operation in an empty linked list. So first of all, a new node will be created. New node will be created like this, and its previous will be null, and its value will be suppose 5, and its next will be null. On an empty linked list you have created a node, okay, using append operation. How you'll be doing that? You can simply visit your code, okay. You'll just say that first of all, I'll just say that I'll be just creating a node, okay. Then I'll check that if my linked list is empty, I'll be simply calling this dot is empty. It will simply return the length, okay. So this dot is empty. This is for an empty linked list. That means previously we don't have any node in the linked list. Now we are trying to add the first node. Okay, so this is for the first node whenever you are adding new element. So what you'll actually do is you will call a pointer. You'll be creating a pointer which is head, okay, head pointer. Head will be pointing to this node, and again tail will be pointing to this node. So you have created a pointer, head and tail, and it will be pointing to the first node when your linked list is empty. So you'll just say this dot head equals new node and tail equals new node, okay. So this is for an empty linked list. But suppose you have first element now, so you can see we have first element. Now we are trying to add new element, second element. So this is our existing linked list. This is our existing linked list. Suppose we create a new element, new node. Again, it will be having previous as null, value as suppose 6, and next has suppose null. Okay, this is a new node. Okay, this is a new node. What I want is whenever you are trying to add the second node or the third node or any node, what you'll actually do is you will simply say that this new node's previous must actually be pointing to this node, right? This node. That means what I'll simply say that this will be having value of instead of this null, this will be actually having value of tail, right? Tail is what? Tail is my previous node. Tail is my previous node. That is this node. This is my tail, right? This whole node, is my tail. That means my new node must point to this previous node, okay, tail. So tail will be always the last node. Whenever you are trying to append, you will just point towards the tail, okay, whenever you are trying to add a new node, okay. So you just said that, yeah, we'll be pointing to the tail. Then what? Then you'll just say that tail, whatever is my tail, tail's next is what? This, okay. I haven't changed my tail. This new node is pointing to the tail. That means I'll just say that for better understanding, I'll just say that suppose the address of this is x0, right? So this will be pointing to now x0. That is the tail, okay. That is the tail, fine. And tail is actually what? Tail is, I'll just say tail equals, right now I'll just say tail is at x0. Suppose tail is at x0, okay. And also the head will always be at x0, because since this is the first element, whenever you change the first element, then it will always be changed. But yeah, initially tail is x0, head is x0. So what I did was I just said that this new node, previous of new node, will be pointing at tail, that is x0, fine. So automatically you are creating an arrow like this, and you will be pointing here. Now what you need to do is you want to go to the previous node. So what I'll just say that previous node is what? Previous node is tail, okay. So I'll just say tail dot next. That means I'm talking about this specific part of tail, okay. Tail dot next will be actually equal to the new node. Suppose the new node's address is x1, okay. So tail dot next will be actually pointing to the new node, okay. So you'll just say that tail dot next is this, okay. Tail dot next is this specific part, and you'll just say that this will be pointed at x1, that means it will be pointing here, okay, fine. Now pointing is done. Now you need to shift the tail. So you'll just say tail, after whole operation, after this you'll just say tail equals new node, which we have created. That's it. So automatically what would happen is tail will be now shifted to here, okay. So now this will become the tail, okay. Again you'll be performing the same operation for any new node, okay. So I hope you got this. This will be the very basic append operation which we are going to write now, okay, which you are going to write. So we'll just say that new node dot previous equals this dot tail. Okay, then you'll say this dot tail dot next, this dot tail dot next equals new node. That means this dot tail dot next will be pointing to new node. Then we have the third thing, we'll just say this dot tail equals new node. Okay, so we have done the same things. You can actually see that this is done here. We have performed three operations. One is we have said that new nodes previous will be pointing to tail. Previous nodes, that is tails next will be pointing to new node. Then I'll just say tail equals new node. These three operations. Okay, so I hope you got this. This is a very basic append operation. And if you still didn't get this, you can watch my previous video. I have done the append operation there also, so you'll get an easier version of that for a singly linked list. Okay, so this is for doubly linked list, so it's a bit complicated, but yeah, definitely if you try to do this on your own, you'll find it easy with the same approach which I have done using the whiteboard, okay, or any paper pen. All right, and one more thing, whenever you append, you'll just say that yeah, new node has been added, so you'll just increment the length, right? So that's how append works. So this is append, and similarly we can perform prepend. Okay, so prepend is very easy. Suppose this is the current state. Okay, prepend simply means if I want to prepend a new element, suppose I want to prepend 4. So 4, if I wanted to append, 4 will be actually appended here. New node 4 will be created and it will be appended here. But if I talk about prepend simply means 4 will be added here and it will be linked from here. Okay, like this. Okay, so how prepend will actually work? Again, a new node will be created first. Okay, again you will be creating a new node. Fine, new node will be created, and 4, and it has no values, that means null and null. Fine, so you can see new node has been created. So what must happen is with prepend, again you just copy this, because if the linked list is empty, so the first step is very easy. Okay, so again you'll just say prepend, prepend. Okay, and you'll just say that you will be creating a new node. We have created a new node, and you'll just say that if the linked list was previously empty, that means length is equal to 0. You'll again directly create a head and tail pointing towards the new node. That's it. But if you have elements in the linked list, that means we already have elements 5 and 6. We want to prepend a new element. Okay, I don't know why my tab key just doesn't work well right now. Okay, let it be. Fine. So yeah, where I was just saying that yeah, when you are performing the prepend operation, so in the prepend operation, again the length will be incremented, but in here, in this case, you are incrementing, like you are adding element before the first element. That means this time head will change. Okay, this time head will change. This time head will change, tail won't change. Okay, so right now let me just clean it first. Fine. All right. So now for this, you can simply say that whenever you are performing prepend, you'll just say that this, matlab, new nodes next will be pointing to head. Head is where? Head is here. Okay. New nodes next is pointing here. Fine. You'll just say that this will be having, now it will be having address of x0. That means it has address x0. Okay. So I'll just write here x0. Fine. I hope this is visible. So now it's pointing to x0. Also, I'll just say that the current head's previous will be now pointing to new node. Okay, whatever is the address of new node will come here. Okay, so whatever is the address of new node, suppose it has an address of x10, right? So I'll just say that this value will now be actually equal to x10. It's like that. Okay, very easy. So that's how things work. And you can see that again this operation has been done, but after this one more step, you can see that since 4 has now become the first element, okay, after complete operation, both operations, you need to shift the head. So you'll just say head equals new node. Okay, head equals new node. So again head equals new node, so you'll just pass head up here. Okay, pass head here. So again you can go to this and you will again say that new nodes next will be the pointing to the head, and heads previous will be pointing to new node, and then you'll just say head will become the new node. Okay, so these three operations are done. So it's very easy. You will just need to understand things, and then you can write code very easily. So append is done, prepend is done. Now what we'll do is, and one more thing, you must make sure that you have incremented the length. Yeah, it's fine. So yeah, you can see things are working fine. Now if I want to add an element in between, insert between, so how can I do that? I can simply call an operation, suppose insert. Suppose I want to insert data at some specific index. Okay, suppose right now we have three elements. You can see right now we have three elements, 4, 5, 6. I want to insert data at after this index. Suppose I'll just say that I want to insert data at 0th index. Okay, you can perform different approaches for insertion, different kind of insertion. But right now I want to insert according to the index. Right now you can see that this is having index 1. Sorry. This is having index 0. Okay, then this is having index 1. This is having index 2. Right, three indexes. I want to add data at index 1. So what must happen is you will be adding new value here. Suppose you are adding value of 100. Okay, that is now at index 1. It will be pointing to new node, the existing next node. So you'll just say now it became index 2 automatically, and it will become index 3 automatically. So it's like that. So you will be performing this operation. So let's do that. So what we'll actually do is we'll be writing scenario here. Okay, so I'll just clean this so that we get a better idea. Okay, so I'll be just cleaning this. So fine, and I think that yeah, this looks good and fine. Right. So what we'll do is now we will just fix this diagram first of all. Okay, so I'll just say that yeah, this is actually pointing. Okay, now it's a straight line. Then it's also pointing here. Right, so this is the current case. Now what I actually want to do is I want to, first of all, I'll be creating a new node. So let's suppose we created a new node here. Okay, new node has been created, and suppose it has value of 100, and its previous is null, next is null. You have created a new node, and you want to insert this at index 1. Okay, that means whatever was at index 1, you can see that this is at, I'll just make this right. Okay, so I'll just say that it's having index 0, it's having index 1 and index 2. Now if I want to add this at index 1, okay, add this new node at index 1, what I'll do is I'll just connect its next with the previous of this, and similarly this will be connected here, and similarly this will be connected here, and this will be connected here, and automatically this middle connection must be removed. Okay, middle connection must be removed. Okay, so it's like that, very easy. But how it will be done? So let's go back first. Okay, so again you have this scenario. What you'll actually do is you will create a new node. Okay, then you have a current node will be what? Current node will always be pointing to head. Okay, so suppose this is the current pointer, I'm sorry, current pointer. So you have created a current pointer which will always be starting from the head. That is the first element. Okay, so you'll always say that yeah, head is also here, current is also here. You'll check that this specific index, okay, that specific index matches to my uh, current node or current value or not. Okay, so you can see that I want to add data at first index, but I am at 0 index. Okay, so I'll just shift my current to this index, okay, things are like that. But what I actually need to do is, instead of this, I'll keep it at -1. let's take another example. I don't want to add at first index, I want to add things at second index. Okay, that is here. Okay, that is here. So what I'll actually do is, current is at 0th index, it doesn't match. Current is at first index. What I'll do is, I'll just stop at one index before my actual value. That means I want to add data at second index, I'll just stop my current here. Okay, that is index minus 1, that is 2 minus 1, that is 1. I want to stop the current at 1. Okay, that is 2 minus 1, that is 1. So current will be actually stopped here. Okay, you will be incrementing the current, but yeah, you will be stopping the current here. Fine. Once you have stopped the current, you will just say that current, actually you can write it this way. Okay, new node dot previous. Okay, new node dot previous will be actually pointing where? New node dot previous must actually point to current dot, actually it must be pointing to current. Okay, it must be pointing to current. New node dot previous must be pointing to current, and current dot next must be pointing to new node dot previous. Fine, I hope you're getting this. So that's how things work. So I'll just write it this way. Okay, so yeah, current nodes, sorry. So let's write this again. Let's write this again. So this is the new node, right? This is the new node. I'll just say new node dot previous. New nodes previous will be pointing to current nodes next, right? New nodes previous, current node next, and current nodes next will be actually pointing to new nodes previous. Okay. Similarly, you will just say new nodes next will be actually pointing to current nodes next previous, that is this. Current nodes next is what? This 6. Okay, this 6 one, and its previous is what? This x0. Okay, so now actually this will be pointing to here, and again I'll just say current nodes next previous is now pointing to new nodes next. Okay, this will be the case, and at the end, you'll just say, yes, this is the case. So we'll be writing the code for that. So let's do that, and it will be better if I write code for that. All right. So this is the operation which was actually remaining, the insert operation. So let's write that. So I'll just say that first of all, you need to check that if it's empty or not. Okay. So for that, you can say that suppose first of all, if the index is less than 0, the user provided index lesser than 0, or index is greater than the length. So you can say index out of bound, something like this. You can show an error. Okay, so after this you would say that if index is 0, that means you want to prepend, right? You want to prepend, you want to add data at the first index. Okay, that means the first node, as a first node. So you'll simply say this dot prepend, and whatever is the data, you just provide that. Okay, else you would simply say that if index is what? Length. Okay, index is equal to length, that means suppose the length is 5 nodes. Okay, that means you want to add data. I think this must be length minus 1, but let's try to do that. Okay, so we'll just say that if index equals this dot length. Okay, that means I want to add data at the last. Yeah, it actually works. It's fine. Yeah, you can see that it actually add things. I'm talking about not the last node available, index after last node. Okay, that means I actually want to add data in the extreme end. That means I'm talking about append. Okay, this is for the append, so it's fine, everything is fine. But now we want to add things in between. Okay, that means starting from index 1, not from 0, starting from index 1 to length minus 1. Okay, this is the range. So I'll just say that else index, okay, just a minute. Yes, we'll be starting from index 1 to length minus 1. Okay, you can add any, you can choose any index. Okay, these index will be there for this else case. Okay, and apart from this, index 0 is covered here, and the last, extreme last, is covered here. Okay, so this is actually the case for our operation which we have written there. Okay, so we'll simply say that since we are in the else case, so first of all, let's create a new node, const new node. Okay, then we'll just say let current node or current you can just create any variable, will be actually starting from the first index. Okay, then you just say that you need to actually stop at the specific index. So you'll just say let count, sorry, we'll be creating a while loop here to actually move the counter. Okay, so you'll just say that while count is less than specific required index. Okay, what I told you was you need to start from the first index, that is 0th index, then you will be stopping at the one index before. Okay, that means if I wanted to stop at second index, that means if I wanted to make change at second index, where I would stop? I would stop at 1. Okay, that means index minus 1. Okay, so current would be actually stopping at 1. That's what I mean. Okay, so here I would just say that let count equals 0. Okay, that count equals 0. So now what I'll do is I'll just say that since this loop is running, every time what would happen is current node equals the next. Okay, that means current node will be shifted to next, and then I'll be incrementing the count. And when it will stop at, suppose I wanted to add things at second index, it will stop at index 1. Okay, if I wanted to add data at 10th index, suppose 10th index, I have 11 12 elements and I want to add data at 10th index, so this loop will stop at 9th index. Okay, 9th index. So it's like that. So you can see that yeah, current node, and I am shifting current node to the 9th index. Okay, 9th index. Now we want to add data at 10th index. Okay, similarly you are talking about I want to add data at second index, I am stopped, current node is stopped at index value 1, right? So now we'll be writing it very easily. We'll just say that new nodes we'll just write the same operation. Its previous will be actually pointing to what? Pointing to current node, right? Current node is previous one. And then I'll just say that new nodes next will be pointing to current nodes next. That what I actually mean is you can actually say, okay, I think we are here. So you can see current is actually here, right? Current is actually here. Its next is what? Its next is what? This. Okay, so I'll just say that this new node will be pointing to current dot next. Okay, it's like that. So we'll just write it here. New node dot next is actually pointing to current node dot next. Okay, and similarly I'll just say current nodes next. Okay, that means current nodes next is actually here. We are actually here. Okay, we are actually here. I'll just say it's current nodes next dot previous, that means x0, this position, this specific position, okay, will be actually pointing to new node. Okay, will be actually pointing to new node. So that's what I will do. I'll just say that current nodes dot next dot previous will be pointing to new node. Okay, and similarly I'll just say current nodes next will be actually equal to new node. That means current nodes next is what? Current nodes next is this. Current nodes next is this. It's pointing to the previous nodes. You can say it's pointing to previous node. Okay, that means we'll be actually pointing to previous node. That means this x1 is actually now pointing to previous node. Okay, it's like that. So that's how things work, and you can just draw it on your own so that you get these conditions better, because this is the operation which we have done before, insert operation, in the last video. So we have written all the 4 conditions. And one more thing, if you are incremented, you can simply increment it this way. Okay, so this is the insert operation, and now we have done the insert operation, and similarly we'll be performing the remove operation. Okay, so remove operation, remove, suppose I want to remove at some specific index, suppose I want to delete data at some specific index. Okay, that means I have 5 elements, I want to delete data at the second index. Okay, that means 0 1 2, third value, I want to delete the third value. How can I do that? By simply calling the index. Okay, the index will be supposed to, so the third value of linked list will be removed. Okay, so first of all you can actually say that this is the case if I have undefined indexes. I'll just say this. Okay, and I'll be starting from current node. I'll just say let current node will be again pointing to head. Okay, and I'll just say that we have 3 cases. First is the, you are talking about the 0th index, that means first node of your linked list. Else if you are talking about the last node of your linked list, else you are talking about any other node in between. So these three cases. Okay, so how things will be actually work. So first we'll be drawing the diagram for that. So let's draw a case again, and this time let's say we have elements 4, 5, 6, 7 in the linked list, and they are actually pointing towards each other, right? They are pointing towards each other. This is the suppose, this is the case, right? So now what I'll actually do is, suppose I want to delete this 6. What I'll actually do is I'll just say that I'll just try pass I'll just bypass this. Okay, I'll just bypass this. So you can see 6 will automatically be removed. Okay, it's like that. So what actually must happen is, suppose this is not the case, I want to delete the item at 0th index. Okay, item at 0th index. So what would actually happen is, if I want to delete the item at 0th index, you know that head is pointing here. Okay, head is pointing here. So I'll just say that also the current node is here. Okay, current node is initially pointing at head. Okay, that means both are here. So I'll just say that this head, if I want to remove this 4, I'll just say this head will be now pointing to current node next. That means this 5. Okay, so automatically head is not pointing here. So the new operations will be automatically not starting from here. That means this link will obviously be removed. Okay, and also one more thing, you need to talk about tail also, right? You need to talk about tail also. So what would happen to tail? So suppose tail is obviously pointing here, tail is pointing here. Okay, tail is obviously pointing here last. Okay, I told you initially tail is pointing at the last always. But the problem is, suppose I had only one element. Suppose my linked list only had one element, and I am about to remove this. What would happen is, head was initially pointing here, and current was pointing here, and tail was also pointing here. Suppose I told you that I'll just say current nodes next is null. Okay, current nodes next is null. So head will be pointing to null. Okay, head will be pointing to null. Now since head is pointing to null, okay, head is pointing to null, so automatically this connection will be removed. And also you can also say, now the I'll just say that if head is null, head equals null, I'll just say tail equals null, or you can just say, yeah, you can say tail equals null. Okay, tail equals null. You need to move the tail also. If head became null, obviously tail will also become null. Okay, and if this is not the case, then you can simply say that if this is not the case, then we are at actually the above case. Okay, so now you can see that I have actually moved the head here. Okay, if I want to remove 4, I have moved the head here. That means this will be removed, this will be removed, and then I'll say head dot previous is actually equal to null. That means the previous of 5 won't be pointing at 4 now. I'll just simply say previous of 5 will now be pointing at just null. Okay, this new head's previous will be now pointing at null. That means automatically this will be ignored. This will be ignored. Okay, so this is the case when you want to remove element from first. Now next case is when you remove the element from the last. Okay, so again from the last you would check that, yeah, this is length minus 1 index, right? Length minus 1 index. That means if you have 3 elements, 0, 1, 2, 7 is at the second index right now. You can see 7 is at the second index. So you would simply say that if I want to remove the last index, okay, you would simply say that the current node first of all will be pointing to the tail. Okay, you'll just say current node will be pointing to the tail. Suppose I want to remove this last index, so current node will be pointing to tail. I'll just declare that. Then you will just say that the tail, this dot tail, will be now actually shifted to current node's previous. Okay, so what I mean is, I'll just say that this dot tail will be actually moved here. Okay, so tail will be now pointing here, and you can say that tails next will now become null. Okay, now become null. That means this connection will be automatically removed. Okay, this connection will be automatically removed, and automatically this will be ignored. Okay, so you can work this way, because that's how things will work. And one more thing, if suppose again the same case, I have only one element, okay, and what I can say that this is This can also be called as the zeroth index. Okay, length is 1, length minus 1 is 0. Okay, so again for length minus 1 also I can actually remove 4, that is only one element is there, I can actually remove there. Okay, length minus 1 index simply means the zeroth index, right? That means if I have one element, I can actually remove that using the second operation which we are talking about, this dot length minus 1. So we can simply say if I want to remove this 4, I'll just say that. Okay, so automatically you can see that automatically index is equal to 0. So automatically the first case will be followed. So I think we don't need to follow this. Okay, so we have automatically written whenever the index value is 0, this case will be followed. Okay, and also the above case will be followed, which we have written by removing 4. But if the index value is length minus 1, then the next case will be followed. But now if I want to remove any element in between, how can I do that? By simply writing it this way. I'll just say suppose we have elements 4, 5, 6, 7, right? And suppose I want to remove this element 6. So what will I actually do is I'll just say that first of all I'll be starting from index 0, that is count is at 0. Then I'll be stopping at where? I'll be just stopping here. Okay, I'll be just stopping here. That means I'll just move current till here, because after this I want to remove things. After this I want to just remove things. So I'll just say current will be moved here. Initially current will be here, then current will be moved to next. Okay, because its index, the index of 6 is what? Index is suppose 2. I want to remove element at index 2. I'll just stop this at 2 minus 1. That means I'll just stop it at index 1. That means current will be pointing at index 1. Okay, I hope you got this. Now what I want is I'll just say current. Okay, we can just actually stop at here. Okay, what we can do is instead of stopping the current here, we'll just stop the current at whatever index you want to delete. Okay, whatever index you want to delete. So again, you will be stopping current here. Okay, finally you'll be stopping current here, and you'll check that, yeah, is my count equal to 2? If count is equal to 2, you'll just stop. Okay, it's like that. Initially the count is equal to 0. So what I'll do is I'll just assume that my current is now at 6. Okay, since my current is now at 6, I'll just say that this current's previous is what? 5. Its next will be pointing to null. Okay, its next will be pointing to null. Okay, it's like that. And no, instead of null, we did a mistake. Its previous, current node's previous. Okay, current's previous, that means this will be actually pointing to current's next. Okay, current's previous will be actually pointing to current's next. Okay, I hope you got this. So similarly currents next will be pointing to this previous. Okay, this is the case. So automatically this will 6 will be removed. Okay, this 6 will be removed. So let's write the code for that so that we get a better idea. So what I'll do is first of all we'll be writing at index 0. I'll just say the condition was this dot head equals current nodes next, because first will be removed, so automatically it will jump to the second one. But obviously if node is not available second node is not available, you'll just say that if this dot head is not equals to null, then you just make the previous value of head as null, right? Previous value of head as null, you just say this dot previous as null. But if head is equals to null, that means automatically tail will become null. Okay, tail will become null. That's it. So this is the index at 0, and then you would say that if the length is -1, that means if I want to stop at the last node, I want to delete the last node, I'll just say that first of all we'll just say that current node is at tail. I'll just say current node will be pointing at tail, and then I can simply say, I'll just say that shift the tail to second last index. Okay, second last index. Then you'll say that now since your tail is at the second last index, you'll just say your second last index, that means tail's next will become null. That means last index will now become null. Okay, will actually be, your tail won't be pointing at any other index. Okay, that means tails next will become null. Your last index won't be accessed from anywhere. Okay, so this is for the last index. Okay, now what we would do is we would say that the third index. Okay, so I'll just say let count equals 0. Okay, I want to stop at the index which you want to delete. So I'll just say while count is less than index. Okay, that means I will stop count whenever I reach 2. Okay, what I mean is, first of all, I'll just say current node will be shifted to the next node again until count reaches, you'll just say that first count is at 0. That means I am at the index 0. I want to stop at index 2. Okay, so again current will be incremented, count will become 1. Okay, again I'll run this loop, count will become 2. Okay, count actually, for initially for count equals 0, this loop will run for first time, then count will become 2, count will become 1, this loop will run for second time, then count will become 2, this loop will actually now about to stop. Okay, that means for the 0, okay, it will run. That means for 0 it will run, for 1 it will run, then after this will be stopped. Okay, so what would actually happen is, initially this current node will be pointing to, first time when the loop runs, current node will actually point to the next node. Okay, that means the first index. Okay, initially this would happen, then count will be incremented to 1, 1 is less than 2, so again this will be, current node will be now pointing to second index which we want to delete. Again count will be incremented, count will become now 2. Now this while loop won't run, so that's how things work. Okay, so this will stop at current node's value as 2, and also count will stop. Okay, count will stop since it's lesser than, it must be less than 2. Okay, it must be less than 2, and current node will stop at index 2. Fine, now what we need to do is, we'll just simply say current nodes previous. Okay, that means index 1 next of index 1 will actually be pointing to one index after. That means it will be pointing to index 3. Okay, it's like that. Current nodes next is index 3, and current nodes previous is index 2, index 1. Okay, index 1's next will be pointing at index 3. Okay, index 1's next will be pointing at index 3, and similarly current node next, that means index 3's previous, will be actually pointing at index 1. Okay, I hope you got this. So if we wanted to remove 2, we are at index 2. Okay, we are at index 2. We'll just say index 1's next will be pointing at index 3. Index 3's previous will be pointing at index 1. That's it. That's how you can perform this remove operation here. Okay, once you have performed the remove operation, automatically you will just say length minus minus, and you can just return, the data you want. Okay, and actually I won't return anything. Okay, I'll just stop it here. Return node remove. Okay, it's like that. Fine, so now we have performed the remove operation also, and you can see it works like that. So let's try to run this, but before that let's try to print this. Okay, let's try to print this. Okay, so I'll just say display, and for displaying, I think we have returned the print operation here, so I'll just copy that directly, and I think this might work, so just paste it here. Okay, so you can see that current will start from head, and while current exists, okay, so current will be moved to next, and we are printing it every time. I think this must work. Let's try that. Okay, so now what I'll do is, I'll just call some operations. Okay, so I'll just say that we have a list, and then we'll be appending first. Okay, we'll be appending first, and let's try to print those values. Okay, then I'll just say list dot display. Fine, so let's try to print those values, and I hope, cross fingers, let's try to run this, and you can actually see that yeah, we have one, and we have first node as 10 and second node as 20. Now if I want to prepend, okay, so I'll just say that prepend 30. That means before 10, 30 will be inserted, and 30, 10, 20, it's like that. So let's try to run that, and now if I try to run that, you can see that 30 is here, then 10 is here, and 20 is here. So you can see that all data is also written here. Next of that is written here, 10's next is 20, and 10's previous is okay, sorry, 30's previous is actually null, and automatically it's taking some value, but yeah, it's obviously null. Okay, so we'll do that, and right now you can see, yeah, it's working perfectly fine. Now after this, I want to suppose insert some value at index 40. That means insert index 1, I want to insert 40. That means 30, 40, 10, 20. It's like that. It must display things like that. So let's try to run this. And if I try to run this, uh, okay, have we committed a mistake here? I don't think so. Let's try to run this again. Yes. So now you can see 30, 40, 10 and 20. So things are added in between. So you can see insert is also working fine. And now suppose if I want to delete the same, I'll just say list dot delete. Okay, sorry, remove at index 1. Suppose I want to remove this 40 which I inserted. What would happen is, let's try to run this again. So now you would see that we have 30, we have 10, and we have 20. 40 is automatically removed. So you can see things are working pretty much fine here. Okay, so that's how you can perform doubly linked list operations. So things are actually complicated here, more complicated than the singly linked list. But if you understood the singly linked list, you can easily understand the doubly linked list. It's not much that difficult. And if you draw things in paper pen, you would understand that better. You can write my code on paper pen so that you get a better idea. Alright, so I hope you understood this, and if you have any doubts, you can ask me on the live chat. I'm just waiting, and I think it's fine. Okay, okay, yeah, thanks. Alright, so if you have any doubts, you can ask me on the live chat or on any of my videos. Alright, I will just reply it as soon as possible, and you can message me any of your doubts regarding anything, regarding web development or regarding competitive programming. I'll answer that. But before ending this video, in the live chat or in the description, you'll find a course provided by Geeks for Geeks. If you visit that link, it will take you to this page. You can check out this course. That is data structure and algorithm in JavaScript. Okay, so this is a paid course, and you can check out this course. It's specially designed for beginners who want to reach advanced level in DSA using JavaScript. It's really helpful for those who want to learn development, web development in some advanced level. Okay, it's still useful in app development and web development both. Okay, and it's still useful in the competitive programming because a lot of platforms support JavaScript as their competitive programming language. So you can definitely use this for JavaScript, or you can also use this DSA logic which you'll learn in this course in any other language also. Okay, so yeah, you can definitely go for this. It will be really helpful, and do check this out. All right, so I hope you understood this, and that's it for today. I will see you in the next one. Till then, see you, have a good day. Bye bye. And one more thing, circular link list is actually pending, but if you demand that, I'll be bringing video on that. All right, so bye bye.